Hi everyone. So today we are going to cover different types of props and uh, job and cron job. So let's start. So far we have covered multi-container pods and init containers. So let's start with pod life cycle. So before going through props, like pod life cycles are the building blocks for the props. So that's why I'm revising that again. So life cycle of pod goes through several phases. Pending. In this phase, the Kubernetes scheduler assigns a pod to node and downloads the container image over the network. As one or more containers have yet to be set up, it's in pending state. Running. Once the pod has assigned and scheduled to a node, and the containers with container or containers within are started, it enters the running phase. Okay. So it might be like init containers and all. Okay, if your application requires multiple workload, then it will schedule all the containers. It will schedule the pods to a node, and inside the pod there could be multiple containers. Okay, if containers within the pod completes their task successfully and terminates, which is the init containers, the pod enters the succeeded phase. If any of the container within the pod terminates with a non-zero exit code, the pod enters into fail phase and indicating the containers within the pod did not complete their task successfully, and Kubernetes scheduler will try to restart the pod again and again because the restart policy of the default restart policy of a pod is always it's always so yeah. Unknown. If the pod status cannot be determined, it is as marked as unknown. So far, I have not encountered this phase. This might occur due to any issue in communicating with Kubernetes API or node where the pod should run. So I have not encountered this particular phase so far. Okay. So this is pod lifecycle. Pod conditions. So these are like gives more like status of where the pod is. Like pod schedule is a condition type. You can see it over in the terminal. Just a second. Yeah. Some neighbors are playing songs, so bear with me if you hear the songs in background. Yeah. So what I was telling is yes, you can see the pod condition. So these are the pod condition. Let's see first what it means. Pod schedule. The pod has been scheduled onto a node. Initialize all init containers as completed successfully. Uh, Containers ready. All the containers in the pods are running and ready. The pod is ready to accept and solve the request. Okay. So if you want to see, let me check if I have like, it is taking so much. I don't know why the status went to crash. Look back off. My CPU is taking so much of load. I don't know why. It is it's taking much of a load. OBS it is. Hmm. I don't know why OBS is taking much of a load today. Let's go. Let's describe the pod. So here you can see the conditions. So I was going through the code as well. I couldn't find this particular condition. So I was able to find this 4 conditions in the code, but I couldn't find this. So I didn't include in this. I don't know what is this a condition in this version only? Okay, 1.32 version. I don't know why it is here, so I need to look into it. But this four condition I found in the code, so that's why I kept it over here. And this is not the life cycle. I should mention the code over here. Let's go to the code. Actually, this. Okay, package. Inside the package we have APIs. Inside the package we have four APIs, and we have pod. Okay, was it here? Don't remember. Pod conditions. No. Where was it? All the conditions. Where to search? Should I search in the public? All the conditions. I need to sign. Okay. I'm sure it was inside the package. Let me. Yeah, found it. It was inside this core types.code. So as you can see, these are the four conditions that we discussed, and the fourth one, which was this pods ready to start container. It's not mentioned over here. Okay, so we are going through pod as well. Good, good. So this is on master branch. We can go to different branch as well, but currently I am on RC branch. This must be. And I'm using 1.32 inside in that as well. It was not. Let's check that as well. Not there. Okay. So yeah. And the focus of this is this ready condition. The pod is ready to accept and serve the request. So this. I should mention this variable. Good. Okay. So this is the particular condition which we are interested in. Ready. So readiness pod prob. By default, Kubernetes assume that when a pod reaches the ready state, it is capable of serving a request. Okay, but in real world scenario, the application may take a few milliseconds or more to actually become ready due to the initial startup delay, like fetching the files, making the database connection and all. So that would make application startup initial startup delay. So we need a way to tie the ready condition to actual state of application running inside the container. Okay, so now we need that ready condition to be actually indicating that the application is ready to solve the traffic. Okay, so that's why that's where the readiness prop come into like picture. Kubernetes provides several ways to define when applications are ready to serve requests. So these are three ways, like set up an HTTP endpoint for web server using use a TCP socket, write and execute a custom script inside the container to verify the readiness. Okay, so these are uh, the way, and you can define it in a pod YAML definition under the specs.container section. Okay, we can define readiness field, readiness prop field. This is the example of HTTP endpoint. You can have TCP socket as well. You can write the custom script for that as well. Okay, checking that if the application is able to solve the traffic now. These are the additional field. If initial delay seconds, if your application takes some time to warm up, use this field to specify the delay before the first probe is initiated. Okay, uh, period seconds specifies how often the prod should be performed. Okay, so how often I should probe the probe the container to be probe the pod to have like it is check if it's ready to solve the traffic. Failure threshold by default Kubernetes tries 3 times. Container checking container is ready or not. You can increase this threshold, allowing more retries before it fills. Okay. So let's say if you have by default it's 3, but you can increase it to like 8 times. Okay, so after probing it for 8 times, if it is not ready, then the pod is marked as a failed state. Okay. Then we have liveness prop. So by default, when application inside the container crashes, Kubernetes will restart the pod in order to solve the request. Okay, in real world scenario, when application is not working due to a bug or container continues to stay alive. Okay, so this is after the like application has startup. Okay, readiness probe was to define if the container is ready to solve the traffic, but in middle of the container, in the middle of uh, traffic serving, if the containers goes down or it has some bugs, then it's in that scenario they are containers are unable to serve the request. So we need a way to check periodically that the application inside the container is healthy or not. So that's where the liveness props can help us. Kubernetes provides several ways to check the applications are healthy or not. So these are the three ways, same as the readiness props. Okay, same as how we define a readiness prop. You can define it under the specs.container sections, and this should be liveness prop, and this should be like healthy. This is also liveness prop. Check health. Yes. And these are the additional field that we earlier talked about. Okay. Startup probe, I have yet to be not written it, so I will write it. But let's cover job as well. So startup probe is similar to like it is used to check the startup prop. So if you want to have implementation of that, we can startup. it is. It's over here. So startup prop verifies the application within the container is started on. So point to note over here is it disables, yes, it disables liveness and readiness check until it succeeds. So this is the special type of prop we can use. Okay, let's go to jobs. So some tasks are short-lived and you need to run it only once, okay, and finish it. Like example, generating thumbnails from image, running analytics, or generating a report. So these are called batch workloads. So job using pods, you can create a pod that performs the same mathematical operation. So like if you want to perform a math operation, okay, then you can use the job, or you can like if you want. So this was like, yes, this was regarding the jobs. Why if we are using jobs inside a pod, then how it will work. So you can create a pod and that runs the main operation. Pod starts, does the job and exists, but Kubernetes tries to restart the pod again and again. Okay, why? Because the default policy is like always set to always. So that we talked about that earlier. Okay, stop from restarting it. So if we want to not have this functionality, okay, then job will be performed, right? So if you want to prevent the restart, then you can set the restart policy to never or failure. Now the pod will run once, but doesn't start after the completion. Okay, so but we still have a problem, right? What if we want to run multiple pods for a job? Okay, so sometimes your task is large and needs to be run across multiple pods. So if you want to run multiple pods, you need to make sure all of them are finished successful. Okay. Um, you may think a replica set will be helpful, but it won't be helpful because they are meant to keep the all pods alive. Let's say you define the replica set to be 3, then all the pods will be like alive. If you delete one of the pod, it will again spun up a new pod. Okay, so replica set won't help over here. So that's where a job comes into picture, where you can create one or more pod and make sure they finish the task. Okay, so this is the like task of downloading the CSV from a website. Okay, this is the one-time job which is done. Okay, so running multiple pods, to run more than one pods, set the completion field over this. Okay, so if you have a requirement of running the pods 3 times, okay, then you can have this completion field, and this is sequential, so it's run one after another. So, so what if some pod fails? Okay, so Kubernetes will keep creating new pods until it gets the desired number of successful completion. So here we have mentioned 3, then it will try to have 3 completion. Okay, so if 2 pods succeeds and 1 fails, Kubernetes tries again until the 3 succeeds. Okay, total 3 total succeeds. Running pods in parallel. By default, job runs sequentially, as we saw. To run them at the same time, and at parallelism field, you can have this field, and this means that you can run now the pods parallelly. You can run your workloads parallelly with the jobs. So same as completion. Okay. So you can create a job like this. Take get a status of this, logs for this, and delete the job like this. So pretty straightforward. Okay. So cron jobs. So whenever you run the like jobs, it runs instantly, right? So what if we want to schedule it at time or run periodically? So that's where the cron job like comes into play. So this is the periodic, and this is like inside the specs we have schedule. This is the job template. This is the exact template of the job. So the job we defined earlier, the definition of job, you should paste over here and it will work. So this is the same syntax which the Unix community follows. So yeah, that's it about cron jobs. We should mention cron. Okay. Okay. So yeah, that's all. And I'm yet to push this on my branch and on jobs. This is good. This looks good. Let's deploy it. So I'm using quads for deploying. Let's pull. So now we have the files, and if we go over here, then we can see the new files are not over here. So let's push it. Wait 1 minute. Okay. Is this leaf? Git and oops, all. Git commit. Git push. So I'm using Vercel for deployment. So as soon as now my branch is pushed, right, a new deployment will be done by Vercel, and it will show up over here. Yes. So we have the files over here. Okay, so cron jobs looks cool. So that's how I deploy my nodes on the website. Yeah. Bye everyone.